All right, here's starting at question number 45. So you're given a point and you're asked to find a trig value using a point. So for this point, the x-coordinate is -12 and the y-coordinate is 5. And the last thing I need to find is the radius. And we have a formula for that. So with our calculator, we're going to do the square root of -12 squared plus 5 squared. That's the formula. So I'm going to open up Desmos. You can press pause and open up Desmos. And that's what I'm going to type in. So I'm going to click on the calculator in the keyboard. I'm going to click square root, and I'm going to type that in. So parentheses -12 squared plus 5 squared. And I get the radius to be 13. Then I need to know the formula for sine theta. Now before, the formula for sine, the definition, was opposite over hypotenuse. Now with the point, it is the y-coordinate divided by the radius. And we have those numbers. So the y-coordinate is 5, the radius is 13, and you have your answer. All right, let's try that again for number 46. So we have the x-coordinate is equal to -15, the y-coordinate is -8, and then the radius. So we know the radius is found. Now it's important to note that you have to use parentheses when typing it in your calculator. You can't just type in -15 squared. You'll get an error message. And we're going to do the same thing with -8. Make sure there's parentheses around it. And we're going to type it in. So here's Desmos again. I already have it here, so I'm just going to erase -12 and make it 15. I'm going to erase the 5 and make it -8. And then you can see the answer there. The radius is 17. And then we need to know the definitions again. So the definition of cosine theta is the x-coordinate divided by the radius. So the x-coordinate is -15, the radius is 17, and you have your answer. Number 47. We're given a point, so the x-coordinate of the point and the y-coordinate of the point. To find the radius, it's the square root of x squared plus y squared. Now notice the coordinates are not negative, so I don't need to put parentheses around the numbers. I can just go 24 squared plus 7 squared. So I'm going to come back here and do the same thing. I'm going to change this to 24, and I'm going to change this to 7. And then you see the radius is 25. To find secant, I need to know the definition. That's the radius divided by x. So the radius is 25, the x-coordinate is 24, and you have your answer. All right, last one like this. You're given a point. So x is -4, and the y-coordinate is 8. To find the radius, it's the square root of x squared plus y squared. Again, we're going to use our Desmos for that. I have a feeling this might be irrational, so we'll see what I'll do with that. So we have -4 squared and 8 squared, and you can see it's irrational. So when it's that way, irrational, I'm just going to type in -4 squared plus 8 squared, not put a square root around it. Oh, let me type it in right. So squared plus 8 squared, and know the number is 80. So I'm just going to write it as a square root of 80. Now, here's another thing. The definition of tangent is the y-coordinate divided by the x. So if I was smarter, I would recognize I didn't even need the radius, so this was not what I needed. I just needed the x and the y-coordinate, which was already given. So the y-coordinate is 8, the x-coordinate is -4, and you have your answer. They also divide to equal -2. Both are good answers. All right, number 49. What quadrant does theta lie in if sine theta is less than 0 and cosine theta is greater than 0? So we need to recognize that the x coordinate is cosine and the y coordinate is sine. So if I read this carefully, sine is less than 0. It's saying the y coordinate is negative because sine goes with the y coordinate. Cosine is greater than 0. That's saying the x coordinate is positive. And then when I think of my quadrants, if I go positive, negative, which quadrant would I end up in for where the angle would be? So I'm going to the right, and then I'm going down, and that's quadrant number 4. So let's try that again. What quadrant does the angle lie in if sine theta is greater than 0? That means the y coordinate is greater than 0. Remember, this goes with the y, you can label it. This goes with the x, you can label it. So if x is less than 0, that means the x coordinate is negative. Draw a little set of axes. If you start in the middle and go to the left and then up, which quadrant are you in? And you can see that we're in quadrant number 2. What quadrant does it lie in? Here it says cosine. We said that's x. Sine, that's y. So cosine is negative. Sine is also negative. So they both are less than 0. If I draw a set of axes to see the quadrants, start in the middle. If I go negative means left, negative means down. So if I go left and down, which quadrant am I in for where the angle is? And it's in quadrant number 3. All right, last one like this. What quadrant are we in? Now this one's a little trickier. Tangent is actually y divided by x. Cosine is just x. So I know the x coordinate is less than 0. I also know that when I divide, that the answer is positive. So this y coordinate must be negative, because when I go a negative divided by a negative, it gives me a positive answer. So we're in the same quadrant we just did. So I go to the left and down, and you can see we're in quadrant number 3. That's where the angle goes in. All right, turn the page. These are all stories to do with sine, cosine, and tangent and finding missing angles and sides. So a tower, here's my tower, casts a shadow, that's along the ground, that's 60 feet long, so along the ground is that. And the angle of elevation up to the sun, so we're going to draw a triangle right there, and that angle of elevation is right there in the corner, which is 65. And I want to know what the height of this tower is. So I'm going to circle the angle. X is the opposite side. 60 is the adjacent side. And I go back to this to understand which trig ratio I use. So O and A. So look at it carefully and recognize that I'm using tangent. So I'm going to write down tangent of 65 degrees equals, and then the side opposite of 65 compared to adjacent, and then I'm going to solve it. So when x is in the numerator, I multiply it together, and then I use my calculator. So now I'm going to go to Desmos. I got to make sure it's in degrees. So if I click on the wrench, make sure it's in degrees, highlighted, and then I'm going to type it in. So this is 60, tangent, 65. I don't even know if you have to use parentheses. No. So that means the answer is 128.67. It says to the nearest hundredth, so we'll do that. That's 2 numbers after the decimal. And that's how tall the tower is. Number 2, Matt is standing on top of a cliff. So here's my cliff. And he's up here. And we know the cliff is 305 feet tall above a lake. And it says the measurement of the angle of depression to a boat. So this is just water. There's a boat here. Look at that boat. So pretty. And then go down. Now, there's my triangle. We have 305, and we're looking down at the boat. The angle of depression is here, made with a horizontal. So the angle here is 42 degrees. So if I want to know the angle inside the triangle, I'm going to just quickly go 90, take away 42, and get that answer. So 48 is inside the triangle. Then the question is, how far is the boat from the base of the cliff? That's here. From the base to the boat, x. And then I circle my angle, X is opposite. 305 is adjacent. Most of the time you're using tangent, not always. We are using tangent of 48. And then the opposite is X. The adjacent is 305. Notice X in the numerator means we're going to multiply. So we're going to go 305 times tangent 48 and then write the answer down. So we're going to go back to Desmos. And we're just going to type that in, 305 tangent 48. And the answer is 338.74, and that's in feet. That's how far the boat is from the base of the cliff. The next one, number 3. Hey, Maria, right here. Thank you for doing that for me. I appreciate it. All right, number 3, Matt is standing on top of a cliff 300 feet above a lake. The measurement of the angle of depression to a boat, so it's very similar to what we just did, right? In fact, it looks like it's the same question. Let's not do it again. Same number, same question. Silly. Okay, number 4, this one. A ladder that is 20 feet long is leaning against the side of a building. So here's my building, and my ladder is leaning against the building. There's my ladder. Notice the ladder is the hypotenuse, and it's 20 feet long. The angle formed between the ladder and the ground, so see where the ladder and the ground where they meet, is 75. And it says how far is the bottom of the ladder from the base of the building. So down here. Be a good reader. So if I circle that angle, X is the adjacent side, and 20 is the hypotenuse. So we're looking at A and H, and know which of these trig ratio uses A and H. So we're doing cosine of the angle, which is 75, and the adjacent side is X, the hypotenuse is 20, and again we're going to multiply and then use our calculator. So it's 20 cosine 75. And I get 5.18. That's how far the bottom of the ladder is from the building, and that's in feet. A ladder, again, 30 feet long, needs to reach. So here's my building again. Here's my ladder. So we have, again, a ladder that is 30 feet long, needs to reach 27 feet up a building. So this needs to be 27 feet. This is what angle of the vertical be. So what should this angle be in order for that to work? Oh, sorry, it says off the vertical, doesn't it? So that's actually this angle here. What should this angle be off the vertical? This is the vertical line, so the angle off the vertical is that angle up there. So again, we're going to circle the angle. 27 is adjacent, 30 is the hypotenuse. So again, we have this adjacent and hypotenuse. That is cosine. Now, whenever I find a missing angle, I'm going to be using the inverse of that to find the angle. And then inside, this is a C, will be the ratio, which is 27 over 30. Here, in order to do that, I'm going to type in cosine, and then I'm just going to do the exponent -1, just like that. That is inverse for Desmos. 27 over 30, and then you have your angle. So that's 25.84 degrees. All right, you are standing 50 meters from a hot air balloon. See if I can draw. There's my bad attempt at a hot air balloon. It wasn't too bad. And it says you are standing 50 meters from it. There I am. And it says the angle of elevation to the top of the balloon is 28. And it says how tall, the height of the balloon here. So I circle the angle. X is opposite. and 50 is adjacent. So it's opposite and adjacent. That's going to be tangent. We know the angle 28, and then the ratio. So opposite over adjacent, which is 50. We're going to multiply, and then we'll get our answer. So 50 times tangent 28. Oh, I don't need parentheses there, but 50 tangent 28. And the height of the balloon is 26.59. And that is in meters. The 5 makes the 8 go up to 9. All right, next. Oh, I don't know why this is here. All right, number 7. Let's read it. So a man is in a boat floating 170 feet from the base of a cliff. So we have a cliff, we have water, and we have a boat. Some guy is floating there on his boat. There's my triangle. It says the boat is floating 175 feet from the base, and the cliff itself is 200 feet. And it says, what's the angle of depression between the cliff and the boat? So we're actually looking for this angle up here. So we can actually draw a second triangle to find this. So if it's 175 down here, it's 175 up here. If it's 200 on the left, it's 200 on the right. And then we can use this triangle on the right. So 200 is opposite, and this is adjacent. So opposite and adjacent means we're using tangent. We're finding a missing angle, so it's going to be inverse, that little -1, and then the ratio is going to go inside. And the ratio is opposite, which is 200, over adjacent, which is 175. So that's what I'm going to type into Desmos. So again, tangent and then I do the exponent -1 for inverse, and then inside is the ratio 200 over 175. And I get 48.81. Let's try another one. You should try it first, right? If you can. John wants to measure the height of a tree. He walks exactly 100 feet. And there he is. And then he wants to know the height of that tree. The angle to the top is 33. And I want to know how tall that tree is. So if I circle the angle, x is opposite and 100 is adjacent. So opposite and adjacent is tangent of 33. And then the ratio is x over 100. Again, we're going to multiply. And then we're going to get our answer. And that's 64.94. Alright, we need to start doing this first and then watching the video. So press pause and try it. The flagpole not bad, huh? Try. There's my flagpole. It says it casts a shadow, that's along the ground, of 40 feet. There's my triangle. When the measurement of the angle of elevation, that's from the ground looking up, is 31 looking up at the sun. It says, how tall is the flagpole? So we're going to circle the angle. X is opposite, 40 is adjacent. So again, we recognize it's tangent of 31, and the ratio is opposite over adjacent. And then we multiply, and then we get our answer. So 40 tangent 31, and that's 24.03, and that's in feet. All right, next one. Kelly is flying a kite. So here's the kite in the sky. Here's the string to the kite. Now that string for the kite is going to be the hypotenuse. So the string, the hypotenuse is 65. There's my triangle. It says the angle of elevation up there is 70. So from the ground looking up is 70. And it says, what's the height of the kite? So I circle the angle. That's going to be opposite and hypotenuse. So that's going to be sine of 70. And then the ratio, which is x over 65. Again, we're going to multiply and then use Desmos. And so it's 61.08 feet off the ground. All right, 2 left. A straight water slide is 170 feet above the ground. So here it is above the ground. You could think of the ladder going up and then the water slide going down. So this is 175, and the water slide is 200 feet long. What is the angle of depression to the bottom of the slide? So the angle of depression is up here, looking down. So I'm going to draw a second triangle on this side and relabel it. So 175 would actually be on this side. 200 can still stay there. And then circle the angle. 75 is opposite, and this is hypotenuse. So opposite over hypotenuse, that's sine. We're looking for a missing angle, so it's inverse, and the ratio is going to go inside. So the ratio is 175 over 200. So again, I'm going to go sine and the exponent -1, which will mean inverse in Desmos, and then 175 over 200. And the angle is 61.04. That's the angle of depression. All right, last one. From a 200-foot observation tower. So here's my tower. Here's my observation tower looking down on the beach. A man sights a whale in the water. So this is the water. There's a whale having difficulty. The angle of depression is 7. So this right here, we're going to make a second triangle. This angle here is 7. We know this is 200 feet. That's the height of the tower. We're going to go and say this then is also 200 feet. Just put it across. And we want to know how far is the whale from the shoreline. So that would be this. On this triangle, we just go back up here. This is the same distance. And we circle and go, okay, that's opposite. That's adjacent. So opposite and adjacent is tangent of 7 degrees. And that's going to be 200 over x. When x is in the denominator, we divide. So we're going to go 200 divided by tangent 7 and then use our calculator. And you get the answer 1,628.87. And that's in feet. That's how far the whale is away. All right, you did it. Mr. G Math over and out. I hope that helped. I hope you tried your best. You can always watch and do the questions over again until you learn it. Until next time.